you for visiting AMARPATHSHALA.com. This lecture is part 2 from the chapter, The Circulatory System. In this chapter, we will learn in detail about how the heart functions. We will also broaden our knowledge on the 3 different types of blood vessels, and we will learn a bit more about what the blood is composed of. So, without further ado, let's begin. In the first part of the lecture of this chapter, the circulatory system, we learned about the heart. We learned that the heart is our major pumping organ. We learned a little bit about few chief blood vessels that supplies our body. As we have seen in a complete detailed diagram, we learned that our circulatory system is composed of major blood vessels that carries 2 different types of blood, oxygenated blood and deoxygenated blood. We also learned that the heart has 4 chambers. Now, in this lecture, we will learn exactly how these chambers supply blood and how this whole mechanism of pumping action takes place. So, how does the heart work? Let's see. Step 1. This is a diagrammatic representation of the section of our heart. In this diagram, you can see that blood from the body enters into the right part of the heart, i.e. the right atrium. And blood from the lungs enters on the left side of the heart, i.e. the left atrium. The heartbeat begins when the heart muscles relax and blood flows into the atria. So you see each heartbeat that you can feel if you put your fingers on this vein here, or if you put your fingers on your throat, or if you put your palm on your heart, that heartbeat that you feel, it starts when blood from the body gets into the right atria and blood from the lungs gets into the left atria. And this is when the heart muscles relax and lets blood in, thus beginning the heartbeat. Then what happens? Step 2. The atria from the right and left atria, both of them contract, and that squeezes all the blood in. The right side of the heart carrying the deoxygenated blood, and the left side of the heart carrying the oxygenated blood squeezes the respective amount of their blood into the ventricles. So guys, what happens is right atria squeezes the deoxygenated blood into the right ventricle. The left atria squeezes the oxygenated blood into the left ventricle. So the atria contract and valves open. Valves, as I have mentioned in my last lecture of this chapter, that valves are flaps of muscles that restrict the backflow of blood. So atria contract, valves open, blood squeezes in from the upper chambers into the lower chambers. And then step 3, the valve close when the ventricles are to contract. The valves close so that there is no backflow of blood. The ventricles are therefore contracting and blood is leaving the heart. At the same time that the ventricles are contracting, the atria are relaxing. So blood is coming back to the heart again from the body and from the heart. So what's happening, guys, if we were to slow down for a minute and realize what's happening, the weight of the situation? What's happening is you start a heartbeat by flowing. A heartbeat starts when blood flows from our body and empties into the right atria. The heart muscle relaxes. making a room for blood to come into and fill into the atria. So blood from the body is carried up by the big vein or the vena cava into the atria or the right atria, and at the same time blood from the lungs is coming through the pulmonary vein into the left atria. As the atria fills up, the heart muscle relaxes, thus the atria can fill up and the heartbeat begins. When the atria is full, it squeezes and the valves open up. Blood flows into the ventricles, which are the bottom chambers of the heart. So when the ventricles are completely full and they are about to contract, squeezing blood out of the heart, the valves they close again, thus stopping the backflow of blood. And the ventricles contract, thus blood gets to leave the heart. And at the same time, the ventricles are contracting, the atria are opening up again. So you see, the heartbeat begins when atria fills up, and that's dip into the heart dip into the heart pressure, and the heart, when atria squeezes, blood goes into the ventricle, and then the ventricle squeezes, blood goes out of the heart. At the same time atria opens up again. So this cycle, atria opening up, atria squeezing, ventricles opening up, ventricles squeezing, this complete cycle is what makes up our heartbeat. Now this process, this might sound that it is a long process and it might take some time, but guys, seriously, this whole thing happens in a matter of 0.8 seconds. Without you fully able to comprehend what the situation is happening, it's over. So this one beat that you feel when you put your fingers on the vein of your wrist here or on your throat there, that what you feel there, the whole atria relaxing and then blood flowing in, and then atria contracting, blood going down, and then the ventricle squeezing out, all of this is happening in one beat. Tough to imagine, isn't it? Now, the cycle repeats itself again and again, and as it does so, these are the different beats that you feel. This is the one beat of the heart. Now that's how complicated beings we are. So, blood, this is how, so we learn how blood is pumped around the body. Now, blood goes around the body in the form of blood vessels. The route that the blood takes, the vessels that carry the blood around, these are the blood vessels. And as we know, there are three different kinds: artery, vein, capillary. So how are they different? How do they differentiate from one another, and what are their functions, or what are they? Let's see. This is an artery. Artery is also known as the biggest or the thickest blood vessels of our body. One of the major arteries that we know full well about, and I have been saying a lot about in this lecture, was the aorta, or the major artery, or the big artery. See, the aorta is the artery that stems from the heart, and it is responsible for supplying blood throughout our body. So this is a big guy, and he has a big job. So if we were to look into arteries in detail, we will see that arteries are vessels that are made up of thick muscles and elastic fibers. Why elastic? If they weren't elastic, they wouldn't be able to squeeze blood in, or if they were fully solid, blood wouldn't be able to maintain its pressure. And arteries are blood vessels that carries blood away from the body. I have always repeated this sentence over and over in my lecture so that you never get it wrong, because if you do, you're you're gonna mess up the whole direction of blood flow in our body. So always remember, arteries carry blood away from the heart. And then the elastic fibers allow the artery to stretch under pressure. So when the blood flow is higher, the blood pressure is higher, arteries have some room for stretching. And this is possible because arteries are made up of elastic fibers. The thick muscles that the arteries are made up of, that is for a reason. See, in the mechanism of pumping action of the heart, we learned about valves. We learned that the valves are there for a reason, which is to prevent the backflow of blood, right? So blood can go in one direction only. If it were to move back, or if it were to misdirect its route, then that is stopped by the flap of muscles we know as valves. However, in case of blood vessels, such as the arteries, they don't really have valves. So what's stopping the blood from flowing back or changing their direction? Say when we're standing, or when we're sitting, or when we're standing upright, blood can take its usual original route. But what if we were hanging upside down? What if we are sleeping in a horizontal or a bent position? What's stopping the blood to not change its direction? What's stopping the blood to not go or stop its direction? It's these muscles. See, these muscles direct or keeps the blood under such high pressure that they can't not behave the way they're supposed to, which means that this high pressure keeps the blood flow in check. This high pressure and thick muscles contract to push the blood along the way they're supposed to. Next comes the vein. The vein is another blood vessel. The vein is a blood vessel that is thinner than arteries. Its wall are also made up of muscle fibers and elastic fibers. But these muscle fibers are thinner than how the arteries are made. As you can see in this diagram, that the veins muscles are considerably thinner than the diagram that we saw of an artery. And therefore, the lumen, or the hole through which blood flows in the vein, is therefore much bigger, and blood can occupy a larger area in the vein. And veins are blood vessels that carries blood towards the heart. Arteries are vessels that carry blood away from the heart, and veins are blood vessels that carries blood towards the heart. Veins, since they are thinner than arteries, they do not generate as high pressures as arteries do. So they don't have the power to put or restrict or push blood in the same way that arteries do. As a result, veins need something to prevent the backflow that arteries can with their higher pressure. That is done by the presence of valves inside the vein. Valves, as we know, are flaps of muscles. And these flaps of muscles prevents the backflow of blood, thereby routing the blood in a specified direction. And these valves present inside the veins stop the blood from going into the wrong direction. The body muscles that surround the veins, they do that so that when they contract and to move the body, they also squeeze the veins. And the thing is, guys, there's vein all around our body. If you look on your wrist or on the palm of your hand, you will find the presence of vein. Veins are much more superficial. They are much more visible than arteries are. Arteries are embedded deep inside, so you can't really see or feel them. But veins you can see, and this is because as they are underlying or overlying the muscles can squeeze and direct the flow of blood. When we are moving, or when we are bent, or etc., etc. So the thing is, body muscles that are surrounding the vein, they do so that when they contract to move the body, they're also squeezing the vein so that they can push the blood along the vessel. So when we are working out or when we are moving something, if we push our hands like these, our muscles here will squeeze the veins that are overlying overlying the muscles in our arm, and blood flow will squeeze up over here. And therefore, if the muscles need more oxygen to perform the task that they are supposed to, they can do so more efficiently because the blood flow in here just increases. Next comes capillary. Capillary is also known as the thinnest blood vessel in our body, because the thickness of a capillary wall is about 1 cell. So guys, the wall of a capillary is only 1 cell thick. That's pretty thin. Capillaries are blood vessels that link arteries with veins. So arteries are blood vessels carrying blood away from the heart. Veins are blood vessels carrying blood towards the heart. Capillaries are blood vessels linking arteries to veins. Capillaries exchange materials from our body cells into themselves, into the blood by diffusion. And this is possible specifically because of their thinness. Being 1 cell thick, when they are lining around our body cells, if that body cells is in need of oxygen and the blood in the capillary is infused with oxygen, there forms a concentration gradient, and thus oxygen travels from the blood in the capillary and into the cell that is in need of oxygen against the concentration gradient via the process of diffusion. So if the capillary walls were thicker than 1 cell, this process might not have been as feasible as it is right now. And this allows exchange of materials through the walls of the capillary. As you can see in the diagram, this is the capillary bed. This is a collection of capillary, which means that in here there is not 1 or 2, but there are multiple amounts of capillaries that are combined together, forming what is known as the capillary bed. This end of the, if you follow my cursor, you can see that this end of the capillary bed will supply to the vein, and this end of the capillary bed right here, blood is coming to the capillary bed from this end, from the artery. So what happens is, blood from the artery is entering the capillary bed via this end, the cursor right here, and then they enter the capillary bed and then they empty into the vein end. Now, see, this is a body cell. inside the capillary bed, the capillary bed isn't something that is out of the blood vessel, out of the body cell territory. It's like a combination of capillaries that is surrounding a group of body cells, and blood is coming to the capillary bed from a particular artery, and then these blood, they are surrounding the body cells and filling into the multiple capillaries that are surrounding the body cells. And as they are filling into the multiple capillaries, they are taking in materials or supplying materials to the body cells. So you see, these are the body cells, and if they need gas, food, chemicals, the blood coming from the artery will supply it to them, or if they are in need to expel materials from them, blood will carry materials away from them. These are the body cells that will either receive or that will either excrete substances. And this area that you see right here surrounding the body cells are capillaries. Now, we learned about the function of the blood, the function of the pumping mechanism of heart. We also learned about the 3 different blood vessels that are present. We learned how exchange happens. Now, let's learn more about the main vehicle that is carrying around all these things, that is being pumped, that is being carried in the blood vessels. Let's learn about blood. What's in blood? What is blood made up of? So, blood is a liquid which is made up of several different stuff put together into a very fine suspension. Blood is made up primarily of red blood cells. Guys, when you see a bleed, when you see blood in front of you, you see a magnificent red colored liquid, and you might think, oh, that's all there is. It's a liquid which is red in color. But it is so much more than that. The red color of the blood is mainly because of millions of extremely small cells known as the RBC, or the red blood cells, or the erythrocytes. So these blood cells, they are dissolved or they're suspended in the blood plasma, and they are brilliant red in color, which gives blood its color. Also found in blood are fragments of cells known as platelets. Platelets are important during the clotting of blood. And why do we need a blood clot? Well, if you accidentally cut your finger, or if you accidentally receive a major slash or a cut on your body, if there isn't any mechanism in our body that stops or restricts the amount of blood that is going to come out of our system, we are eventually going to die. So there needs to be something. There needs to be something that is causing a barrier, that is causing a kind of a wall that is further blocking the flow of blood away from our body. And this is done mainly by the platelets. Other factors are obviously involved, but the platelets are forming a mesh network, which is kind of like a sieve that you use during sieving tea. This is kind of this platelet network actively prevents the flow of red blood cells away from the cut. So what happens is, when you get your finger cut, before the blood clotting happens, you bleed out a little, and then the platelets, along with other factors, forms a kind of a net, a meshy network, which traps red blood cells, and that kind of forms a bandage of sort, which prevents the further flowing out of more blood. Next up, in blood, we have white blood cells. Guys, these are what you can say they are the troops, the armies of our body. In every country, there is an army that protects it from invaders or protects it from terrorists or enemies. In our body systems, these are done by the white blood cells. There are several different types of white blood cells, but their function mainly remains the same. It is to prevent the body from the attack of pathogens such as bacteria, such as protozoa, etc., etc., etc. And these white blood cells either engulfs them or chemically destroys these pathogens that get inside and tries to harm our body. Blood also, apart from blood cells and apart from blood cells and platelets, blood also contains dissolved gases, as I have mentioned in every one of my lectures over and over again. So one of these gases are carbon dioxide, that mainly comes when we respire food, which get dissolved in the blood, and then when gas exchange happens in lungs, carbon dioxide is then respired out. Then we have digested food. See, like I said, when we eat food, it's digested in our digestive system, something that we will learn in detail about in the next chapters. So this digested food that are small enough is then absorbed in our blood, and they stay in our blood until they're needed by our body cells to be respired and then to provide energy. Blood also, the liquid part of the blood, the part of the blood where all these things are present, all these things are suspended. For example, think of a juice. This is the month of Ramadan, right? You all have iftar with your family. You sit for iftar, and then you also drink juice. What happens when you make juice? You take in water, you put in sugar, and then you put in some powdered juice, and then you also put in some lemon, and then you add anything else if you want to. See, our blood, it's kind of made in the same way. There's a liquid part of the blood that is known as plasma, and in the plasma, all of these different things are kind of mixed together, made into a suspension. And then you have hormones. Hormones are special chemicals that are made in our body, and they have verified functions. Hormones, a couple of them, they are responsible for our growth. Hormones such as insulin, they are chiefly responsible for the utilization of glucose, i.e., if glucose is if the amount of glucose is in excess inside our body, they are converted into glycogen and stored into the liver. And then when glucose is the amount of glucose lowers down, it is then converted into usable glucose again and then released with the bloodstream. This is done by insulin and glucagon. And then there are hormones that control secondary sexual characteristics in males and females. So hormones, they have a diverse action stream. and these hormones are made into our body. But the hormones are carried from where they are produced to where they are necessary via the blood. So you see, inside the blood, inside the liquid that we know as blood, we have all these different things. We also have oxygen. We also have waste materials. Now see, this is a diagram that shows the composition of blood in a capillary. You can see that there are some red dots and there are some really small, almost star-shaped structure, and there are some almost triangular white structures. So these red dots, they are the red blood cells, as we have discussed a little bit earlier. And the almost triangular white structures are the white blood cells. And these somewhat star-shaped structures are known as the platelets. And everything that is flowing inside this liquid is known as the plasma. Now next comes the red blood cells. The red blood cells are the special cells inside our blood that gives the blood its color. What are the red blood cells like? Red blood cells are biconcave disc-shaped structures that are cells that do not have any nucleus. So red blood cells are circular cells that are concave on both sides. Thus, they are known as biconcave. And since they are circular or disc-shaped, they are in together known as a biconcave disc. Since red blood cells are so small in size and shape, they do not have any nucleus. And the biconcave, as in a concave structure on both sides, allows them to bend or squeeze when they're going through like really narrow capillaries. Red blood cells contain a chemical which is known as hemoglobin. If you have followed the lecture on respiratory system, you know what hemoglobin is. But in case you haven't, I will give you a brief summary on hemoglobin. Hemoglobin is a chemical that is found in the blood. It has an iron center attached to a globin protein. So heme or iron is attached to a globin protein, and this chemical is what it's a chemical that is specially designed to carry oxygen. So when hemoglobin temporarily attaches itself with an oxygen molecule it has received during the gas exchange process, it is known as an oxyhemoglobin molecule. And this oxyhemoglobin molecule is present in the red blood cell, and it is carried along via the red blood cells. So red blood cells are very important, especially for carrying the respiratory gases into and out of our system. They can change shape, like I said before. The thing is that them being a biconcave disc in shape, they can change shape in a great extent. They can fold, they can bend, and they can squeeze through narrow capillary systems. So the exchange or their passage along the way is never really stopped or hindered. So up until now, in this part of the lecture, we studied about the function of heart. We studied about different kind of blood vessels, and we also studied about what the blood is made up of. And this concludes part 2 of our lecture from the chapter, the circulatory system. And up until part 3 comes up, have a nice day.